This panel is really about what is likely to be the future of transportation, and with me I've got I think three of the best people we could possibly have to talk about this subject. Nate Lewis, professor at Caltech, renowned in the really in the clean energy sector quite broadly, both the clean energy generation as well as has a deep understanding of the modes of transportation as well and how that energy can be used effectively. Martin Eberhard, co-founder and CEO of Tesla, and in interest of full disclosure, I'm chairman of Tesla, and so I'm a little biased in that regard. And then Vijay, it's science correspondent for The Economist, has written quite a bit about the future of energy and the future of transportation. So I thought we'd start off by just asking Vijay for his views on the future of clean energy and clean transportation at sort of a macro view, perhaps both domestically and internationally, but however you'd like to address that question. Then go to Nate and ask about some of the underlying technology and science, and then go to Martin and talk about the specific point solution, which is Tesla, and why that point solution versus some of the other candidates. So Vijay, if you'd like to kick it off.
Thanks, Elon. It's great to be here. Thank you for having me. I'm given the distinguished nature of the rest of the panel, you'll see I'm the joker in the pack. I'm the journalist, but nevertheless, I'll strive valiantly to sketch the scene. I do think that the world's energy system, as it is fundamentally unsustainable. And we've talked already at this conference in a couple of ways in terms of renewable fuels and so on. We'll talk some more. But I think the three broad pillars of instability that make it unsustainable, that's not to say all fossil fuels are at an end or anything like that. I don't argue that. But the needlessly dirty and inefficient way we use fuels today has three linkages that make it unsustainable. The first, and often neglected, is the link between energy and poverty. There are perhaps 1.6 billion people on Earth who have no access to modern energy at all. And it's folks in places you would expect, sub-Saharan Africa, southern India, indeed the whole subcontinent, parts of Latin America, where it's mostly women and girls that walk miles a day to fetch crop residue, cow dung, whatever they can get their hands on, burn it in very inefficient ways in makeshift cook stoves, and the resultant indoor pollution is atrocious. But that's one aspect of this. The current system is failing them. The second aspect, of course, we see in the headlines, energy and geopolitics. The rise of the developing giants, concerns about oil security, China's emergence as a very large oil importer. I think we're seeing the implications, rightly or wrongly, and there's a lot of good economic arguments why it doesn't make any sense for countries to worry about ownership of oil assets. It's a fungible global commodity. Nevertheless, that's not how governments think. China and India are quite insecure about ownership of oil. You've seen a buying spree through Africa, the Caspian, Latin America, the tar sands of Canada. And the final pillar, of course, is environmental. Local pollution, which kills people today, and climate change, which has tremendous potential to be very disruptive and be a much bigger killer in the longer term. In all of this, I think there's one aspect of the energy system that's the thorniest. And having spent a lot of years looking at this, it's right to look at coal. Coal is a problem, particularly in developing countries. But the real nut, the thorniest nut in the energy problem, I think, is oil. And that's because, of course, it has the geopolitical linkage with resources concentrated in a few countries in the Middle East in terms of conventional oil. You have the economic potential for shock. I mean, there will never be a global economic shock over windmills. It's not going to happen. There may be a local conflict with with the Kennedys or something, but we're not talking about the same kind of shock as with oil. So you have the economic potential for shock, and of course, we can do use of coal today in power plants that's compatible with climate goals, be that with carbon capture sequestration, IGCC. There are a number of ways to address this problem with even off-the-shelf technologies. Expensive, but off-the-shelf. As long as you burn gasoline in an internal combustion engine, you're going to emit carbon dioxide. Right. And we can even persuade every coal-burning utility in America to either clean up the carbon or to switch to available proven alternatives, whether it be wind or solar or nuclear. if it comes to that. But there's no way in hell we're going to persuade 300 million Americans to get out of their cars. As long as we have the current paradigm, the 100-year paradigm of the internal combustion engine and gasoline twinned, I think this is going to be the thorniest nut of the climate problem.
Absolutely. In fact, Vijay, a phrase that I've heard you use before, which I think is actually very important for people to remember, and I hope I wasn't preempting you in getting to that, but that there's a lot of interest in hybrid cars, but as the phrase I've heard you say is, if all the world drove a Prius, we would still be 100% addicted to oil.
Absolutely.
And so, I mean, sometimes people, I think, forget the fact that really a hybrid is a gasoline car with a little more mileage.
Yeah.
So,
I think the Prius is not the car of the future, but it may be the essential stepping stone to all of the cars of the future in the impressive advances it has made in efficiency, the hardware, particularly the software involved, and the battery technologies. It's an important and interesting stepping stone, particularly coming from within the industry.
Sure.
I think it's also important in raising public awareness. That when you see a Prius, you see another person that's thinking about the problem we have with oil consumption.
Absolutely.
Right. A Prius is definitely a better thing than, say, a less fuel-efficient gasoline car, provided people don't think that it is an end solution. Right.
So in closing, I would say that's really where our efforts need to be concentrated. And I actually see a lot of hope, and I think that there's a tremendous amount of dynamism on both sides of that equation in terms of oil and looking at alternatives. And certainly you folks are working on electricity. Others, we heard, working on renewable fuels. Efficiency itself, I like to think of as an alternative fuel. It's often the cheapest. It should be thought of as an alternative if it reduces use of gasoline. And long-term hydrogen, we can have a vigorous debate, as Martin and I were having just in the foyer outside a few minutes ago, about hydrogen. I'm personally agnostic. Sorry to let you down, guys, but I think that society wins when all of these alternatives compete in the marketplace and help reduce and ultimately replace oil. I think that's great. I actually think oil will be around for a long time. There's no shortage in the world. The whole Hubbard Peaks thesis is easily, in my view, debunked, but that's maybe another topic for another panel. I do think the problems associated with oil are so great that a multiplicity of arrows in the quiver are necessary, and I'm delighted to see all of them succeed.
Yeah, absolutely. Actually, and before we go, Nate, I think one thing it's worth mentioning is that I think the normal economic forces of pricing is actually a very good way to drive change. The unfortunate thing that we have right now is that with gasoline and with a number of other options, the cost of CO2 in the atmosphere is not taken into account at the gas pump. You have a similar problem, common good problem, with, say, fishing stocks. We're really depleting our ability to put CO2 into the atmosphere. There's a limited amount we can put into it, and that just isn't captured with the price at the pump. And so that's where, unfortunately, I think the normal pricing mechanism that would drive change is not actually driving change as fast as it really needs to. So, Nate, could you talk about perhaps your views on the underlying technologies? Why you think, I mean, one might be better than the other, and if I think it might be helpful if there are things that people can look up afterwards as well that they may want to learn more about the details of these things.
Great. I think there are, let's pick up on the transportation theme, put it in perspective. Roughly 20 to 30%, depending on how you do the arithmetic, of our total energy that is consumed by humans goes into transportation. So we absolutely need to work on that sector and cut it down. But there'll be a point where cutting it down enough is then marginal gained, and you work on something else. So we need to get to that point and then go work on the other things that affect energy security, national security, and climate security at the same time. And although we have this enormous debate now about ethanol and corn and cellulosic, and we don't have technology. In fact, you can't fight the laws of physics here. And there are two keys that actually the Prius starts to realize, the old General Motors EV1 Impact realized, and now the Tesla car is realized, and they're always going to be there. One is weight. If you have to go around in something that weighs 3,000 pounds to pull 300 pounds of passengers, that's just bad physics. There's no reason why you can't make materials that are stronger than steel, that are much lighter than steel, and not have to pull around 3,000 pounds to pull around 300 pounds. And if you don't lightweight cars, all of these other arguments, we don't have range, we don't have enough resource, they're all exacerbated. If you do lightweight them, all of a sudden, your equivalent mileage has gone up by a factor of 2 or 3, and things which were only 70-mile range are now 200-mile range, and everybody's happy. That's engineering number one. It's inevitable. The transportation will go toward lightweight, high-strength materials. Number two is it's inevitable from the laws of physics to not escape the fact that internal combustion engines are 17% efficient of energy in to power delivered to the wheels, and electric motors are 85% efficient. So there's no way around that fact, right?
Well, actually, the Tesla motor is 93%.
93. All right, so I'm conservative. The point is that
our peak is in the 90s. If you really
90 to 85,
Close enough.
close.
Your numbers are reasonable.
So the prime mover's going to be a lightweight car driven to the wheels by an electric motor. That's going to happen if we're ever going to get efficiency in the transportation system, which I believe for various reasons we will. Then you can debate. You can debate about whether or not most of your energy comes from onboard electricity, whether it fully comes from onboard electricity, whether some of it comes from onboard gasoline or diesel or biofuels or something else, but you're already using so much less of whatever it is to take to drive the wheels that by the time you put those first two things into place, you've cut transportation demand down to the 10% or 8% total energy consumption level, and then it's a debate about the margins as to how we move ourselves around. And that debate is going to clearly end up in the end with the fact that we're going to start to eventually run out of atmosphere if we don't run out of oil. We may have already run out of atmosphere before we run out of oil. And the alternatives to power that car are pretty limited because you have to go to where the energy is. And we either clean up coal or we build a whole lot, like thousands of nuclear power plants, or we find a way to use the sun. Biofuels are one way, provided you don't use more energy to make ethanol from corn than you get from the ethanol in the first place. Another way is direct solar to electricity, and there are other schemes. So I think those are three inevitabilities in the long term. We'll have lightweight cars, we'll have electric drives to the wheels, and then we'll discuss where the energy source comes from, but we won't be using enough of it that hopefully it'll matter very much.
Absolutely. I think that's one of the big advantages of an electric vehicle is the disintermediation of source and use. So you can make the energy in a wide variety of ways.
Right. If you carry the energy on the vehicle in an electric form, if you're not bringing a liquid fuel along of some sort, then you have complete independence of the fuel source and your transportation. And we can choose to make our electricity with coal or nuclear power or solar power or biofuels, and whatever comes along in the future continues to power the fleet. You no longer have to make the decision at the car.
And you could even add to the margin if you didn't have enough range, because there is a cost versus range trade-off now in storage and batteries. And the Prius trade-off is really most of your range and drivability comes from gasoline, and a little bit comes from regenerative braking plus some buffering of the torque. But it's really coming mostly from the gasoline. In a plug-in hybrid or in the limit of a battery-powered Tesla-like car, it's all coming from onboard electricity. There are various other engineering designs that might be mostly electricity and a little bit of range from something else, a liquid fuel, maybe if we ever figured out how to store it, gaseous fuel like hydrogen. But that's almost a third-order issue at that point. As long as you've gotten the weight down and you've gotten the electric drivetrain in, then these other things are engineering versus cost solutions that will let the marketplace play out.
Right. I know you're also a big proponent long-term of solar power, and I am too, actually. I think if I can make a prediction, since this is sort of a conference about the future, is that around the midpoint of the century, a majority of our electricity will be direct solar derived, a combination of solar thermal and photovoltaic.
Yeah, well, I think the reason for that is when you eventually wake up and somebody hits a gavel around our planet and says, we're not going to continue to emit CO2 to levels that will double or triple where it's ever been breathed by any human ever, the mere fact of doing that is going to lead us to decide how much energy we need and where we can get it from. And then there are only a couple big cards we have. There's clean coal, but that's oxymoronic unless you can bury the carbon dioxide for millennia, because that's how long it lasts in the air. So when we put it down somewhere, it's got to last for 1,000 years and not leak at 1% a year. Nobody knows we can do that now. So we need to explore that, but it's not a done deal. We could build, to provide all our energy, a new nuclear power plant every single day for the next 38 straight years. That's what it would take, and they would all have to have plutonium in them because there's not enough uranium. That's what the nuclear card means if you play it on a big scale. Or you get some of it from the wind and most of it from the sun, and the inescapable law of physics is more energy from the sun hits the Earth in 1 hour than all the energy consumed on our planet in an entire year. Nothing else is even close by orders of magnitude. If you're going to rob banks, you go to where the money is. If you're going to take energy, you go to where it is, and that's from the sun.
I think this is a very important point, actually. I'm sort of tend to think of things in a physics way as well. And if you look at the possibilities, we'll generate electricity long term from either direct fusion, if we're able to make that work, or indirect fusion from the sun. That's it. I mean, that'll be the heavy lifting. There'll be some other things around on the margins, some geothermal, wind, various things here and there. But really, the heavy lifting has to come from solar long term.
If I could jump in, Elon, if you don't mind.
Sure.
I think that the cute idea about going where the money is when you're robbing banks reminds me to inject a little bit of economics into this. I think realistically, while the numbers on uranium in the ground, to the best of our knowledge now, and reasonable forecasts are probably right, and the proliferation issues are there, I think that we're probably going to see nuclear as one solution in countries that, like China, like others, we're going to see that contributed. And in terms of coal, the U.S. is the Saudi Arabia of coal, like it or not. We have it, we're going to use it. And here's the reason why I think we should use it, for the following reason. Not because we don't have options, we do. And not that because we may not at one point adopt some sort of carbon price and motivate low carbon technologies. It's because China and India and South Africa in particular are endowed with vast quantities of cheap, dirty coal that they are burning today and they will continue to burn. Here's my prediction. These countries, and I cover them and I know them well, I don't believe there's a desire to move quickly on action for the sake of climate change. And there's a very strong moral argument made, and I have made it on the pages of The Economist as well, that India and China rightly argue that the rich world, particularly the United States, must move first and move seriously on climate change.
Absolutely.
The rich world created the problem. If you look at the stock of greenhouse gases in the air, developing countries feel quite strongly, whatever they might say on UN stages. In fact, any actions that China has taken, and India even more so, that might have had a beneficial effect on climate change have been because they've been concerned about local pollution, the co-benefits. And I think that's a more fruitful way. The reason I say this is they have that coal, it's cheap, it's domestic, meaning you don't have to worry about LNG imports or anything else, the geopolitics of it, and they will burn it using the really crummy old pulverized coal technology that makes up more than half our electricity fleet. I mean, we have a dilapidated energy infrastructure in this country. We're keeping it going with Band-Aids and duct tape. It's obscene how inefficient it is. And there's no reason they're not going to do the same unless the rich world buys down the costs of whether it be carbon capture and storage, IGCC. I mean, there's a plethora of technologies that they're almost 1970s technologies in a way. This isn't really rocket science. And I don't have to tell you about rocket science. So I think that's the economic and sort of realpolitik argument why coal's on the table. It's the big kahuna. We had better find a way to make it climate compatible, because if we make a strong bet only on solar, much as the technocratic arguments you make are impeccable, the real world is going to go ahead burning that coal.
Absolutely. Well, even if the developed world, even if it's just U.S., Japan, and Europe, if there's an aggressive move towards clean energy, we're talking about 60% of the world's energy consumption there, approximately, between Europe, U.S., and Japan. So
this year.
Sorry?
Now.
Okay. Yeah. But I mean, if at least 60% of the world's energy consumption is moving in the right direction, that's certainly very helpful. But of course, for developing countries, it's hard for us to tell them, why don't you have a lower standard of living, because we're concerned about the climate. They got bigger, issues from their perspective. So,
but bringing this back to transportation, the beauty of building a car that runs on electricity is that you have this freedom, that you can choose to use coal, to use clean coal, while you can to build some nuclear power plants if you want to. As we move toward a more solar-powered world, we make the decision on the transportation today, solves the oil problem now, and allows us the freedom to move in whatever direction turns out to be the right way to produce clean energy.
Absolutely. And Martin, could you talk about the Tesla point solution? Why electric cars and why this approach and all that?
So I started out when I founded Tesla with the same agnosticism. I did not originally start off to build electric cars. I looked at what transportation technologies existed, and for me, the most important thing was to separate energy carriers from fuels. Gasoline is a fuel. Hydrogen is not a fuel. It's an energy carrier. There isn't any natural source of hydrogen. It's all produced by cracking water or other technologies. So separating those, you need to do the math and figure out how much of a real source energy you're using, whether that's coal or crude oil or natural gas, it takes to move a car down the road a given number of miles. How many miles per gallon of crude oil can you go in your gasoline car? How many miles per kilogram of natural gas can an electric car go? And if you do that math, it turns out that electric cars, as you pointed out, are vastly more efficient than the other technologies out there. Not just a little bit, but a lot more efficient. And this is what led me to found Tesla Motors and to start making cars that are powered by electricity. Of course, we all know about electric cars have been around. There were some here in California because of the zero emissions mandate in the 90s. And, all these cars have gone away. And if you look at them, you get an idea as you look at all the electric cars that have been around before, that these were made by people that really didn't think you should drive. The driving was a bad thing. You should drive a little golf cart, that'd be fine. And I think that this is not appealing to the way Americans think about our cars. We think about cars as part of our personality, as an extension of our personality, and trying to convince somebody to give up on their whatever car that they've bought now and go to something that's a major compromise in style and in image and in performance and so on is just asking too much of human nature, I think. So we set out instead to build a car that is really the best car we could possibly make, actually better than gasoline cars in many ways, as a way to reintroduce the idea of electric cars, as a way to break into the market and allow us to build, ultimately, a full spectrum of electric cars that meet every kind of need.
Right, absolutely. Exactly. It's worth noting that Tesla doesn't expect to see a substantial change from building a few thousand sports cars a year, but as Martin was alluding to, the plan for Tesla is to increase, ideally by an order of magnitude with every subsequent model. So Model 2 would be, it's going to be a four-door, five-passenger luxury sports sedan at around $50,000 and made in 10 to 20,000 units a year. And then Model 3 will hopefully be somewhere in the order of 100,000 units a year. But then there are, I think, two other ways in which Tesla or other electric car companies could have a very positive effect. Tesla is going to be licensing, or rather manufacturing, the electric drivetrain components for other car companies. So not trying to keep the technology close to its best or unique to Tesla. And so I think some of those will bear fruit. And then the third way, which may be the biggest way of all that Tesla is able to make a difference, is by disproving two commonly held beliefs in the auto business. One is that the technology is not there to produce a viable electric car, and the other that even if the technology was there, that people would not buy it. So I think Tesla needs to show that it's technologically possible and people want to buy it, and then I think that will serve as a very good example to the auto industry. I know we've got a really short amount of time left, and if we could take some questions, I'm sure you've got some questions.
Hi, Dave Hardwick. We're talking a lot about the North American market. What I keep wondering about is what does it look like in India for the transportation, or in China as you develop personal transportation options that are electricity-based? Could you guys speak to that, please?
So there are electric car ventures right now in both those countries, in India and in China. So they are also aware of this issue. I think that in these countries they see this for themselves as a path toward independence from the need for oil.
If I could jump in there. I think that the potential for a technology leapfrogging is tremendous, and it's often discounted, but I think particularly because the incumbents, the oil industry and the conventional Detroit auto industry, have proved so risk-averse, relying often on political lobbying that often works against their own interests, that we're seeing some of the brightest ideas emerging. If you look at flex fuel technology, it was actually American companies that developed flex fuel technologies, but it was very expensive. They never really wanted it to take off. Brazil adapted it to local conditions. 80% plus of new cars sold in Brazil today use flex fuel technology, can easily run either on pure ethanol, pure gasoline, or any blend of the two. Similarly, Fischer-Tropsch, a process that South Africa pioneered, is now becoming commonplace for producing gas to liquids. In China, I mean, the vice chairman of GM himself has said he thinks hydrogen fuel cells will take off in China before they take off in the United States. And the new science minister, just appointed a month ago, is a huge believer, former Audi engineer, a huge believer in hydrogen, but and is developing expertise in China on fuel cells around the country, not just because of the environmental reasons, but because they see the potential to use domestic coal. Again, they have almost limitless quantities of domestic coal as a source of that hydrogen, and therefore get over the geopolitical problem of being reliant on Middle East oil, which their security planners tell them the US military can cut off if we ever get in a conflict with the US. Domestic coal to hydrogen, wacky as you may think that idea is something they're thinking about very seriously. And when you consider that the OECD countries, US, Europe, and Japan, all of our fuel infrastructure and highways are already built out effectively, we have a problem of legacy costs, stranded assets, incumbents who are very powerful. Look at China and India. What of the cars and other transportation means they're going to have in 2050? Maybe they have 20% of that in the ground right now. They have a future yet to be built, and they could take a very different path. I think they're really thinking very seriously about taking that different path.
I think you're headed down the right path there. The question, I should have been a bit more specific. When I go to India, what I don't see is automobiles so much, but I do see motorcycles. And I'm assuming the same thing is true in China. So who's developing things around two-wheel transportation that you can speak to?
Just interject. I think this just opens up, we don't have much time, the bigger issue that, let's not put the horse before the cart here. There are 600 million people in India that are going to go in China, they're going to go into cities that are yet to be built. There's only 1 in every 100 Chinese that has a car right now. So you have a tremendous ability by good urban design of cities that are yet to be constructed around the mistakes that we have made of very long commute distances, of absolutely no mass transport in most cases, and needing cars to obviate that, and then you don't really worry much about whether or not they want to buy them because they won't be driving them very much. So it really doesn't matter whether it's motorcycles or cars. It matters more that we think about that future of urbanization and of getting out of poverty and take a different path toward the end goal and factor into that 2 wheels or 4 wheels or electricity or not in the most efficient way.
What will it take for solar to be successful?
Lowering the cost.
All right.
Or charging the cost truly of carbon dioxide into the atmosphere, or some combination. You absolutely need to do some combination of those. It's clear that when energy is in concentrated form right now into the ground, pulling it out and burning it is a much lower cost than making it yourself from something 93 million miles away from us. Right? It's going to be that way for a little while. Energy is a substitution product. We already all have it. Oil is cheaper than bottled water. We don't pay the true costs of it in a variety of externalities. Unless you stimulate the marketplace, you can't expect that you can come in on a high-cost product that's a substitution and equivalent for something you already have and expect it to gain tremendous market share and scale at an unfavorable cost point all the way down the learning curve.
And yet we're at a capacity limitation for solar panel production around the world right now.
We are, but it's still a tiny fraction of our total power.
Yeah, but it's a good sign.
And I apologize, we're a few minutes overdue, so thank you very much for coming today. All right.